Hi students, now we are going to discuss about the conservation of isospin and its component, that is I and I3, that we need to define. Okay, we already arranged our hadrons in multiplets according to its spin, strangeness and baryon number. Okay, two additional quantum numbers could be defined, and these are isotopic spin or isospin. Okay, and it is conserved in all strong interaction. Second one is the projection of isospin vector along the z-axis in the imaginary space, which is defined as I3, and this is conserved in strong and electromagnetic interaction. Okay, now this isospin is related to the number of particles in the multiplets. Okay, and if you have n number of particles in a multiplet, then you can define your I, the isospin I, is equal to n minus 1 by 2. Okay, so I am just giving you a few examples, like for the case of a singlet, that is eta 0, lambda 0, omega minus. In this case, you have I is equal to 0 because your n is equal to 1 and 1 minus 1 equal to 0, so it is 0. And for the case of a doublet, that is like a nucleon, that is proton and neutron, or kaons, that is k plus and k0, or psi particles I0 and psi minus. In this case, I is equal to minus half, and for the case of the triplets, your I is equal to 1. Okay, and this isospin was introduced or defined by Heisenberg in order to characterize the nuclides of various isotopes. Another thing is, it has nothing to do with ordinary spin or angular momentum. This is just actually it is coming from the word isotopes. Okay, that is why it is called isospin. Isotopic spin, it converted to isospin. Okay, even though it has nothing to do with the our ordinary spin or angular momentum, we can make some analogy. Okay, so as you know, if you have the magnitude of spin is j, then the j can orient itself in 2j plus 1 different states with respect to a defined direction in space. Okay, Heisenberg assumed that similar particles such as the neutron and proton are two different states of one basic particle, like the two spin states of the electron. Okay, so he therefore denoted these states by the direction of an imaginary vector with properties similar to the properties of the spin. So to have two states, that vector must have a length of half. അല്ലേ, നമുക്ക് ടു സ്റ്റേറ്റ്സ് ഉണ്ടാവും. നമ്മൾ എന്താ എടുക്കുക, നമ്മൾ ഈ ഒരു പെർട്ടിക്കുലർ സ്റ്റേറ്റിൻ്റെ ടു സ്റ്റേറ്റ്സ്, വൺ ഈസ് ലൈക്ക് ദിസ് ആൻഡ് അനദർ ഈസ് ലൈക്ക് ദിസ്. സോ ഹിയർ വി വിൽ ടേക്ക് പ്ലസ് ഹാഫ് ആൻഡ് ഹിയർ മൈനസ് ഹാഫ്. Let we have a proton and a neutron like that. So we will take I is equal to minus half, sorry, I is equal to plus half, and I3 is equal to plus or minus half. Okay, similarly, if you have a psi particle, then psi 0 and psi minus. Here also I is equal to half and I3 is equal to plus or minus half. And in the case of a pion, if you have a pion, then this is pi plus, pi minus and pi 0. Here I is equal to 1 and I3 is equal to plus or minus 1 comma 0. Now the conservation of I3 is simple and it is just a counting rule, while that of the isospin I is more complicated. It is little bit complicated. Okay, isospin is like angular momentum. Isospin conservation correspond to invariance under rotation in that imaginary space or in the I space. Okay, actually ഇത് സ്പിന്നുമായിട്ടൊന്നും യാതൊരു റിലേഷനും ഇല്ലെങ്കിലും it has lots of analogy with your spin and angular momentum. ഓക്കെ, അപ്പോൾ ഈ ഐസോസ്പിന്നും നമ്മൾ സാധാരണ പറയുന്ന ആംഗുലാർ മൊമെൻറ്റം പോലെ തന്നെ ഐസോസ്പിൻ കൺസർവേഷൻ മീൻസ് ഇറ്റ് കറസ്പോണ്ട്സ് ടു ഇൻവേരിയൻസ് അണ്ടർ റൊട്ടേഷൻ in ഐ സ്പേസുള്ള ഇൻവേരിയൻസ് ആണ് നമ്മളുടെ ഐസോസ്പിൻ കൺസർവേഷൻ ഇൻഡിക്കേറ്റ് ചെയ്യുന്നത്. ഓക്കെ, ആൻഡ് സ്ട്രോങ് ഇൻട്രാക്ഷൻ doesn't have or do not have a preferred direction in space. Okay, strong interaction do not have a preferred direction in I space. One more thing is there is an interesting relation between I3 and other quantum numbers. Okay, that is Q, the charge Q is equal to I3 plus half A plus S, and here I3 is the component of isospin along the z direction, and A is the baryon number and S is the strangeness, and this is called Tillman-Nishijima formula. And this eventually related to our hypercharge, because A plus S is nothing but hypercharge. നമുക്ക് വേണമെങ്കിൽ ഹൈപ്പർചാർജിന് എങ്ങനെ കൊടുക്കാം? Y is equal to 2 times Q minus I3, because A plus S is nothing but your Y. So you can write Y, the hypercharge Y is equal to 2 times Q minus I3.